Hello viewers, welcome to our channel TechStreetz. In this video, let's try to understand what is bigo, what is time complexity and space complexity. Let's start with what is bigo. By definition, bigo is the language and metric we use to describe the efficiency of algorithms. If you don't know when your algorithm gets faster or slower, you will struggle to judge your program performance. Let's try to understand this with a real example. Consider a scenario where you have a file on your hard drive and you need to send it to a friend. We need to send this file as soon as possible. How will we send it? We can send by using Gmail or some FTP transfer or some other electronic transfer. If the file size is small, let's say the file size is 1 MB, then it will take 10 seconds to transfer that file to your friend. If the file size is 10 MB, it will take at least 1.5 minutes to transfer that file to your friend. Let's say the file size is 1 TB. It will at least take 1 day to transfer to your friend through electronically. We have another option where you can directly give your file to your friend physically. Instead of electronically or some by Gmail or FTP, you can directly give that file to your friend physically. Let's say it will take a half day to give it to your friend physically. When you try to give that file to your friend electronically, as the file size increases, the time is also increasing. But when you try to give it to your friend physically, the time is constant. Whether you are carrying 1 TB file or 1 petabyte file, it doesn't matter. The time is constant. In computer science, this is called time complexity. Let's understand what is time complexity. Time complexity measures the amount of time an algorithm takes to run and function of the size of input. It helps to understand how the running time of an algorithm grows as the input size increases. Let's try to understand this with an example. Here there is an integer array where in this array you want to find out the maximum element in that array. Let's consider an array which is equal to 1, 2, 10, 5. Here you want to find out the maximum value in the array. We know the maximum value is 10. Let's try to understand this. So we are traversing each element one after the one and trying to find out the maximum value. Consider this max value as 1. Okay, now let's see the other element. Is 2 is greater than 1? Yes. So the max value is 2. And then is 10 is greater than 2? Yes. So the max value is 10. Is 5 is greater than 10? No. So the max value is 10. Like this, we are trying to find out the maximum element in this array. So let's try to understand the time complexity of this algorithm. Here the time complexity is pico of n. How? Here we have n elements. That is, here we have 4 elements. We have traversed these 4 elements to find out the maximum element in the array. Suppose if we have 5 elements, we'll traverse all those 5 elements. So basically in this array, if you have all the n elements, we need to traverse all the n elements to find out the maximum element in that array. So the time complexity of this algorithm is big O of n. Next one is space complexity. Space complexity measures the amount of extra memory an algorithm needs in addition to the input data. Let's try to understand this place complexity with an example. We have a swap function which take two integer variables a and b and we need to swap those two variables. Let's say a equal to 5 and b equal to 10. We need to swap these two values in these variables. How can we do that? Let's try to see in an example. We have a glass of milk and a glass of water. We need to swap these two things. How can we swap them? Let's take an empty glass and we'll pour this milk into this glass. Now this is empty. Now take this water into this glass. Now it become water. After this glass empty, take this milk into this glass. Now this become milk. That's how we have swapped this water and milk in these two glasses. Now apply the same scenario here. Let's take a temporary variable which is empty. In this temporary variable, put this value 5. Now A is empty. Now place the B value in A, which is 10. Now in this B value, place this temporary variable, which is 5. That's how we are swapping these two values in these variables. This algorithm uses fixed amount of memory regardless of the input size. Here, the space complexity of this algorithm is bigo of 1 because this algorithm uses only fixed amount of variables like A, B and temp, which does not change with the size of input. So the space complexity is bigo of 1. If you like this video, please share with your friends and don't forget to subscribe our channel TechStreetz.